Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. Actually, we're extending 52 weeks of Python. We are in week number 59. This lesson is on cracking passwords using brute force. Now, if you've been following along, you know I created this module. I've renamed it to Password Crack because this is where I'm going to keep a couple of modules that are talking about cracking passwords. We talked last time about using a dictionary search of well-known passwords. This time we're going to be using brute force. And as I mentioned before, there are tools that exist out there that do many of the things that I'm showing you, that do dictionary searches, that do brute force password checking, etc. I'm not attempting to recreate those. I'm using cracking of passwords as a vehicle for teaching you about Python and some different Python things. In this particular lesson, I'm actually going to be teaching you a couple of things. One is going to be queuing and using the queue class, and the other is using multiprocessing. If you recall from previous times talking about what we're doing in concurrency, we talked about different things like async IO and multi-threading. We're going to talk about multiprocessing this time because you need to do that in order to do parallel processing. So it's very important to do this in a non-IO bound environment. So that is what we're going to be talking about. This is the general design of the application that I'm going to be talking about. I will be demonstrating how it works and walking through the code, of course. Let me get rid of these because we don't care about these. I mentioned them just so that you understand, all right, that those exist and we know that they exist, but we're going to talk about how to actually write code that does some of these things, queuing, multiprocessing, in the context of creating a brute force password cracker. So without further ado, let's get started. So we are examining this topic of cracking passwords. Now, the last lesson we looked at cracking passwords using a dictionary. The idea is that you would have some hashed password value. You wanted to know what its actual value might be. And so you have a dictionary of possible passwords. The one that we used actually had 15 million different passwords in it. And so we looked at the way that is done most often that I've seen online, where we're reading the file one line at a time and comparing it to see if it actually, our hashed password is the same as that, and if it is, then we know what the actual value of the password is, its unhashed value. And so we did it using a file, which can take a long time, especially if you're doing it at scale. We read everything into a Python dictionary, which of course would be exceptionally lightning fast in order to do that. The downside was that it used up a lot of memory. In fact, we could only, on my system, utilize about 4 million of those passwords. And then we also read it into a database. If you're going to be building a real live application, you'd probably use a database. The downside is the upfront cost can be kind of steep, but the upside is the database stays around forever, and it also is very, very fast. So we looked at doing that, cracking passwords using a dictionary. Today, we're going to be looking at cracking passwords using brute force. What is brute force? This idea is that you generate every possible combination of numbers, letters, special characters, and you go through and you compare it against the actual password to see if it actually is the correct one. You can do this a couple of ways. One would be to try to actually log in. That, of course, if you have an intelligent system, then it will block you after a few, so that's probably not the best idea. A possible other application would be that you have the actual hashed value, but it's not going to be something that is a well-known one like these that are in the dictionary, and so you want to go compare your hashed value against the actual password's hashed value and then see if you can crack the password in that way. In our code, which is called using brute force, we're actually going to be looking at the actual password itself. I won't go through the step of hashing, but you probably would be using hashed values. Now, probably immediately you looked at this and said, this would be a good candidate for using something like multi-threading or some type of concurrency in order to do that. And you're absolutely right. So if you wanted to, you could find many of these brute force tools online. There's something called Hashcat. There's John the Ripper. There are many different tools that can do password cracking for you, but our intention in this class, as you know, is to learn Python and to get more proficient at that. So what we will be doing in this lesson is exercising our Python skills and learning a few new ones in order to develop some code that will be doing brute force password cracking. So that is what we will be looking at in this lesson. So brute force cracking of passwords. I want to show you a little bit about how that works. So you'll notice first over here, here's the code that I have created. So I have a little bit renamed things and reorganized it. I'm calling this module password crack. I probably still don't like that name that much, but that's what we're looking at, cracking passwords. And I last talked about using the dictionary. Remember, we did the dictionary and we found things via the file read, via the Python dictionary, and then via a database, which is right here. So that's what we did last time. I renamed that just so if you are pulling down the code, you'll know what to be looking for. This one we're looking at, I'm calling it using brute force. And so we will get into that code in just a little while. But first, as I said, let me demonstrate it. So I'm here in my password crack. So I'm going to say Python 3 using brute force. And now I have a few parameters that I can pass in. One of them is the number of processes that I want to use. What am I talking about? Well, I can do multiprocessing. This is something that we're going to learn about that's new and different, and I'll explain that in a little bit. We can use multiple processes to take care of, make things go a little bit faster if we so choose to. So that's one of the things I can pass in. I can also pass in what I want to compare against. One is I can say numeric, I can say alpha, so that I will check actual characters, and I can also pass in special. So those are three options that I can pass in. Now, just to make this simple, I'm going to just do numeric, and it's going to default, the number of processes is going to default to the number of cores that I have, and we'll talk about that in a minute. So you can see I've started two processes. The search characters that I'm looking for that I'll test in this password, I'm assuming this password is only numeric, so it's only going to test these. A lot of times when you look online and you find these brute force things, this is true of one of the ones that David did and another one that I've noticed, they often will say, okay, this is just a numeric password. Sometimes that's what the Wi-Fi passwords tend to be. Anyway, I'm going to type in something here. So I'm going to type in 123, and it's going to go off and try to crack it. And you can see it found it in 0.007 seconds. So that was pretty quick. Let's give it a little bit more difficult task, 1, 2, 3, 4, and see how long that takes. Well, that took also 0.007. So basically, it's just the overhead of launching my processes. Let's give it a little bit harder. 1, 2, 3, 4, 5. Now I have 5 different characters. So again, it took a little bit longer, not a ton longer. It's still under a second, but 0.105. Now, as you might imagine, when I'm doing this brute force, and I'm going to show you this visually in just a second, it starts at 00000, and then it tries 00001, 00002, etc., and goes forward. So you might expect, if I was to do something in the other order, in fact, I'm going to go 4, 2, 4, 3, 2, 1, and let's see how long that took. So that took 1, 2, 3, 4 took 0.007, and 4, 3, 2, 1 took 0.68. And in fact, if I was to do 9999, you would see that my brute force program takes even longer in order to do that. So here you're just getting an idea. I could use 5 characters, but you can see it will take a while. And I am using both of my cores. If I start more of my concurrency, I'm using multiprocessing in order to do this. I'm not able to take advantage of other cores, and so I don't really get any advantage in that. Just for kicks, I did do 1, 2, 3, 4, 5. Let me try 5, 4, 3, 2, 1. So this is a 5-character password. It found it, and it didn't take all that much longer. It took like 0.105. It took 0.687. Now, if I were to go one more character, even if I started with 1, it would go up significantly. What I'm going to do here is I'm going to stop this, and this time I'm going to say numeric, and I'm going to say, I'm hoping this is the keyword that I'm passing in. Yeah, so here's my search characters. Sometimes you'll see people online do search characters, but they only do lowercase, while everybody accepts lower and uppercase these days. So this is my list of potential characters. So you can see and imagine this is probably going to take a little bit longer. Just for kicks, let's start with an easy one. 1, 2, 3. It didn't take it very long. Let's try 1, 2, 3, 4. Again, because this is starting at the beginning at 0 and 1, it's probably going to go pretty quick. It takes longer than it did before. In fact, let me see if I can get up here to 1, 2, 3, 4. It took 0.007. Down here, it took 0.256. So that's, I don't know, what is that? It's 30 times longer or something of that nature. Yeah, somewhere around there. So it took a little bit longer. If I was to do 1, 2, 3, 4, 5, you can see it's still working on it. This one is going to be in the multi-second range. I cannot, frankly, remember how long this actually takes. Okay, it took 13 seconds to do that. Now, if I was to say 5, 4, 3, 2, 1 or 9, 9, 9, 9, 9, that's going to take longer than we want to wait in order to do that. But you can see and get a general idea. This is only with numbers and letters. If I was to add special characters, then as you can imagine, it would take even longer. In fact, why don't I do this? I'm going to get out, and I'm going to do the same thing and say minus minus special. And now you can see I've added these extra characters on the end that it's going to be looking for. So I'm going to try, let's see, what should I do? I'm going to try a small number of, like if I was to do 1, 1, 1 here, that's going to go very fast. If on the other hand, I was to choose this question mark and say, well, how long will that take if I do question mark, question mark, question mark, then this is going to take significantly longer. And I know I did this before when I was testing it. I can't exactly remember how long it takes. Let's do this though. Oh, there it is, 11 seconds. Let's look over here. Do you see this? Here is my processor, and you can see my processor kind of got hammered a bit because it was having to work really hard. And not only that, but I have 2 cores, and you can see that both of them were working full time in order to do that. Let me do something different. Let me do this exact same thing. Whoops. See if I can get out of here. I'm going to do exactly the same thing, but I'm going to use 1. Processes 1. Looks like I need to make this a little bit wider. Processes 1. I don't think I've done this and looked at the graph. So let's see. So you can see I started only 1 process. Now I'm going to do, what did I do? Question mark, question mark, question mark. And it took 11 seconds. So I don't know what this is going to do, but we probably will see this when it begins to get started. You're going to see Do you see this? One of my CPUs is going up really high, and the other one is, well, they're kind of going back and forth. I suspect that it's actually splitting time amongst the two CPUs as I go through all of these different things because I have a queuing mechanism. But you can see only one at a time was pegged, and it did take not quite double, twice as long, but significantly longer. So this is the application that I have written. This is where this gets useful, looking at the CPU. That's why I have it there. Yeah, now let me show you visually what I'm talking about, and I just want to do this. This looks a little bit ugly, so I don't want to spend too much time on this, but I am going to take these two lines and I'm going to uncomment out. They're going to print out my test password when I run this. So what I'm going to do is I'm going to do this, and I'm going to say I only want to have numeric stuff, but I'm going to do one process so it will be less ugly. Unfortunately, when you have multiple processes, notice when I say processes, this means I'm adding one extra process. So there's the main process plus the one that I create. Here we are, we're going to be running it. I've created one. My password is, now if I do 1, 2, 3, you're not actually going to be able to see anything. What it's going to show is this testing is going to go through what it's testing. If I was to do 1, 2, 3, 4, 5, now you may be able to see a little bit. Did you see that going? You could see it kind of went up and incremented, and we found the password, and the second thread kept going, or the second process kept going. To make this more interesting, I'm going to say 55555, and this is going to actually run so that you'll be able to see it going through all of those numbers. And that's basically what this is all about. If I had alpha also, then you would have seen the alphabetic characters, the letters, actually going through in this process as well. That's basically a visual look at the brute force. Hopefully you were able to see that. Okay, next let's look at the code. So let's get a high-level overview of this code. Now this is my code using brute force. As you can see, it is about 120 lines of code, so that's not too much. It's separated into two sections. One is this function called check password, and then there is basically the main function called main, surprisingly, and that is where stuff gets done. Now I do have a picture of what actually is going on, and this kind of describes it. So let's pause for a moment and look here. Here's that main function that we were looking at. What it's going to do is it's going to create the processes. That's these things over here. These are long-lived processes, so they will sit here and they will listen on the queue that they're aware of. There's actually 3 queues, but for simplification purposes, I'm showing just the one main one that has the work that we're going to be doing. And what this main function is going to do is it's going to load up a bunch of requests, or put requests into this queue for password cracking brute force stuff to get done. And when it's all done, it will basically clean everything up and go back for the next password and begin again, and then shut down at the very end. So what are these actual these functions that are running as processes going to do? They're going to get something from the queue. They're going to begin and generate a whole bunch of passwords. It's going to compare the passwords to this actual password in order to see if we have a match. So we're basically going through everything. We have a number of these different processes. As I said, it makes sense to have as many of these as there are cores on your system. We'll get into this a little bit later on about the way that this actually works and why we use processes and not threads, things of that nature. And basically that's what's going to happen. We're going to put a bunch of these requests onto the queue. These will get processed, and then we'll try to attempt to find the password. So that's the general overview. Let's begin to look at the code in a little bit more detail. So first let's investigate and understand what this thing is that I've been throwing around, this word called queue. What is it? Well, we've dealt with queues before. If you've been through this class, then you know we've used RabbitMQ, which is a queuing mechanism that works across processes, even across different systems. And we've used that to send messages to workers and for a number of purposes. This is a much simpler thing, so that's the good news. A queue is basically like what you see in this picture. Somebody puts things into a queue, and then somebody or somebodies, plural, pulls things off of the queue. So when you have multiprocessing or multi-threading, this is a good way to organize the stuff that you are doing. So you put things into a queue, and then these workers, threads or processes or whatever they might be, listen on the queue, they pull them off, and then do the work that was requested. In our situation, that's going to be to generate a bunch of passwords and see if they match the actual passwords. The code itself is pretty clear cut. I'm going to be importing queue right here from multiprocessing. You can import queue from a number of different places. Because I'm using multiprocessing, which I'm going to explain why in a little bit, then because we're using that, we're going to use the queue class from that. So I'm going to have 3 queues. The main one that you see the picture of here is going to be the request queue. This is where I put requests to look at and investigate passwords into the queue. And so that is my request queue. A response queue is how these workers are going to be able to respond to me, telling me whether they found a password or not. And then lastly, the terminate queue, if somebody has hit return or if we found the password and we want everybody else to quit, then I created something called the terminate queue. The main one that we want to look at right now is this request queue. So what is this request queue used for? Well, you can see if you're an eagle eye here, you can see it's something I pass into when I create this process. We'll come back to my process creation in a minute, but this is basically the same thing that we did with threads. We created a thread and then we started it. Here we're creating a process and we're starting it. We're passing in the target and we specify the function that is going to be used for this, the duration of this thread. But it's not a thread, it's a process. It's the function that's going to get run for this process. And these are the arguments that we're going to pass to it. The brute force request queue, response queue, and terminate queue. And if you recall, if I go all the way up here, my check password, that's the function that's going to be used for my process. Here's my 3 parameters, so that matches there. I'm going down into the processing stuff, and I'll get to the queuing stuff in just a minute. This is where I start all of the processes. How many processes do I start? Well, I start num processes. That value we've retrieved when we started the whole thing. It's passed in here. And the default is going to be the CPU count, which is going to be the number of cores. So basically, I'm going to start the number of processes that I have cores, or I can use a different value if I choose to do so. And again, this is the actual function that will get the code that will get executed. Those are the parameters I call start, and then I need to keep track of them because I need to be aware of these things to, if I want to shut them down, other reasons that you may want to do that. So this is my starting of the processes. Now, getting back to my queues, remember I have this request queue. What am I going to do with the request queue? Well, I'm going to come down here and basically I'm going to retrieve the password. So this is where I get the password. Once I have the password, my strategy is going to be to go through this entire list of characters. So I've created this list of characters. Remember, it's the thing that I print out. Let's see if I have this printed out somewhere. Yeah, here's my search characters. That case, I only had numeric. When I had all of them, these were all of my search characters. This is just my strategy. What I'm going to do in order to put things into the queue is I'm going to create something called check info, which is going to be, as you see, a dictionary. I'm going to be passing in the first character. That's special because of the way that my function is written. I pass in all of the characters, and then I go and I pass in the password length. This is the length of the password that was typed in. So I'm only checking if the user typed in 1234, I'm only checking in for a length of 4 for the password. Now, obviously, when you are cracking a real password, you're not going to know that value unless you're doing something that is similar to what this is done. And therefore, you may want to start at like 1 character and then 2 and then 3, 4, 5, etc. But for this application, I'm using only the length of the password to make things a little bit quicker. And I'm passing in the actual password. Here's the queue thing. Remember my BF request queue, that thing I was talking about before I distracted myself with all this stuff? That's the queue that I created. How do I put something into the queue? Pretty simple. I do a put, and I put that thing into the queue. And I'm going to do this for every character. So over here, when I have this many, I'm going to have this many items in that queue. When I only have numbers, then I'm only going to have 10 items in that queue. How do they get pulled out of the queue? They get pulled out of the queue, as you see right here. This is my request queue. It got passed into me when I got started. I'm looping here forever or until I exit. The way you get something is you do a get. And pretty simply, I get the data right here. I don't have to worry about JSON or anything else because this is all within my Python application. So everything is in terms of Python data. If you recall with RabbitMQ, I needed to convert things from and to JSON. I don't have to do that here because it's all within my Python program. So that is how I use this particular queue, and that's what in general a queue is. Hopefully that queue issue makes a little bit of sense, and we'll now dive a little bit more into the actual code in more detail. Okay, so let's look at check password. Remember, that's the code that runs in the process. These little processes that I create, they are running this check password code. So let's look at what it does. As I say, it's a long-lived process, so it is going to be running forever until it gets told to exit. And so we're in this while true loop forever. So what do we do in the while true loop? The basic thing is at the very beginning, we do a get from this queue. So if there's nothing in the queue, we wait right here because this blocks. If there is something in the queue, then we get it and we process it. And the data that we're getting from the queue is in this variable that I'm calling check info, which is a dictionary. The first thing that I'm going to do is I'm going to get all of my pieces of data into my local variables, which I didn't have to do, but I just did it. First character, remember I'm calling these one item in the queue for every first character there is in that search, the search characters. And so this one will be like it will be if it's just numbers, then there will be a message for 0, a message for 1, a message for 2. And what I'm going to do is I'm going to take that first character and I'm going to append everything at the end of it. So if my first character is a 0, then I'm going to append 0000, 0001, 0002, etc., iterating all through that. That's the thing that we're going to be iterating through all of those. So these are the pieces of data that I get from the item from the queue that we've dequeued. And now the next thing, these 2 lines of code right here, the first one especially, you're probably not going to understand this, and I'm not going to go into details. It would take a while to explain all of the different functions that are available in this package called iter tools. It's more for people whose professional job is writing software in Python. There are many different methods that you can call. One of them is called product, which gives you a generator that is going to generate that thing that I was going to telling you about 0001, 0002, 0003, and then eventually 1001, 1002, etc. And how big that is, how long the number of characters are, is going to be the password length minus 1. The reason I remove 1 from it is because we're going to be using the first character. The first character will always be that first character that was passed into me. So if the letter A was passed into me, then I'll be going through A 0000, A 0001. I'll eventually be going through the letters as well, special characters, etc. But my test password is going to be the first character plus the join of all of these next characters. Now I'm going to tell you this. You can debug it. I don't think I'll have time to debug this and look at it. What this is going to give us is a list of the next characters. This list, you can turn it into a string. You may have seen me do this before. Basically, I'm taking a null string and doing a join. This is a weird Python thing. It does make sense. It does end up taking all of these next character items in this list and creating a string out of it. That's all you need to know, is that that's what it is going to end up doing. And so basically I'm going to have the first character plus, the first time through it will be whatever the first character is in that search list. If it is this thing right here, then it would be 0000 for the first one. If the length is 5, then there will be 4 of them. If I was only doing letters, then it would be AAAA and then AAAB, etc. I'm hoping that makes sense. I keep repeating it. My apologies for doing that, but I'm hoping that repeating it will make it stick. And that ends up with being my test password. Remember, we are brute forcing this thing, going through it. I'm going to compare that with the actual password. If it is there, that's great. I can exit what I'm doing, and what I'm doing is this for loop right here. So this is my activity, this for loop, which actually has an else on it. If I find it, then I send a message on the response queue. Remember, we talked a lot about the request queue. I actually have a response queue, and that is what the main program is going to listen on. I don't have that shown here, but there's a response queue. It is going to listen for responses. Once it has put all of the items into this queue, then it's going to wait for all of the responses to come back. And so what it's going to do is it's going to, if I find it, it's going to do found. If I do, this is the third queue, if I need to terminate in the middle of what I'm doing. So for example, one other process found what we were looking for, that means I can quit. So if there's an item in this queue, that means if it's not empty anymore, then I'm going to send a message back in the response queue that says that found is false. I just want to make sure that I put responses, whether it is a response of true or false. So here I'm terminating early. If I get to the end, remember my for loop, I can have an else statement. If I get to the very end and I've not broken out, then I'm going to do this, which is to put a message in the response queue that says I didn't find it. This is just as I said, my contract is that every one of these messages will have a response. So whether I found it, or whether I am terminating early, or whether I got through everything and didn't find it, I am going to send that back. And now the only way that I ever exit out of this process is if I send an exit message into check info. And that is what happens if, as you probably saw, let's see where we are here. Yeah, if I just hit return when I'm done, and for password, then it ends up exiting, and that's what happens in that situation. So that is check password. Next, we're going to look at the main program and see what it does. Okay, let's look at what the main function does. That's this thing right here, and I've hopefully put up this information about what it does. First, I'm going to create all the processes. That would be each of these things. Then I'm going to put request into queue. Remember, I'm going to put a single request for every character in the search characters. And then what I'm going to do is I'm going to wait for them to finish and clean everything up. And then we'll go back and do the requests again, the second and third of these bullets here. So let's look at the code. This is main. We've looked at this before, so it should go relatively fast. Here is my request queue, response queue, terminate queue. This is where I build my characters string. So basically I start with nothing. If the user passed in numeric, remember those are the arguments that were passed in, numeric, alpha, and special. If they were passed in, then I'm going to add 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If numeric was passed in, if alpha, I pass this in. If special, I pass in these things. And notice I had to escape out for certain of those items. Now the next thing that I do is I'm going to come down here and I'm going to start the processes. We talked about this before. I have my number of processes that I got also from the arguments that were passed in. This is the standard, same thing I did with thread. I create a process, I start it, and then I append it. I don't think in the code that I actually use this. No, I actually do when I go through and put requests for exiting in. So I do keep track of my processes. So it's important that I do that. So let's look at what we do. This is the main loop of work that happens. Let me make this so you can see as much as possible. So it's a while true loop. Once again, first thing that happens is the user is going to input the password. If they don't input anything, then I'm going to go through all of my existing processes, and in the request queue, I am going to send them a message, but instead of this being a request for work, it is going to be, this is the check info thing. It's going to say exit is true. Remember this thing that we were looking at up here? Check info, that's what comes in from the queue, the actual data that comes in from the queue. And here I'm checking to see if the string exit is in check info. So down here, this is where I'm actually putting that in there. This is where I add this thing, this exit. So I could have created something called check info and put it in there, but it's just as easy and a little bit quicker. You just have to kind of understand what's going on. That's my check info. And then at the end, as we looked at here, we will end up exiting brute force password finder. So that is what this particular thing does. Now the real work is right here, and this is where I have my time where I'm keeping track of it. Remember, I put a message. I'm going to do a put for every character in chars. Chars is my search characters, the thing that I print out right here, my search characters that can be very long, or it can be just these. If I go up here you can see it's very long. So I'm going to go and put one message in for each one of those. Let me get back to my for loop here. So this for loop, I'm putting a message in. Every message is going to pass in the actual message that I put into the queue is this data, and it contains the first character, which is the character. So for something like this, it will be, the first one will be 0, then 1, then 2, then 3, etc., all the way to the end for all of those messages. After that, it will be this entire string. So the entire string of all those characters will be in there. Then it will pass in the password length. That's the length of what the user typed in. Remember, I'm cheating a little bit, so I'm only, if they typed in 4 characters, then I'm only using that. And then the actual password itself. I probably could have just passed in the actual password and done the length itself, but for some reason I didn't do that. Then I put it into the queue. So now I'm done creating all of this stuff. I'm done putting everything into this queue here. So all of my requests are now in the queue. I'm done with that. And now I can just wait for everybody to complete. And basically what I'm doing is I'm going through for all of these, for every one of these characters, and I really don't care which one responds to me in this response queue. I just know that I want to go through the number. I want to do this the number of times that there are characters in chars. Does that make sense? So if there are actually, let's see, let me get down to the bottom. If there's this many characters, what is that, 10? Then I'm going to go through this loop 10 times, and I'm going to expect to get 10 responses. Remember I said when we were looking at this check password function in this for loop, I want to make sure that I put a response in this response queue, whether I find it or whether I am told to quit or whether I went through the entire process and did not find it. So I am expecting to get a response for every one of those. So that's what's going on in here. and I'm going to look at the responses that I get. I only care about the one that says that it was found, and if I did, I'm going to extract from the response info the password, and I'm going to specify how long did this take. Notice I'm using the time that came from response info. That's the actual time that it took to find it. And if I go through all of these, once again, here's an else statement that goes with the for statement. If I go through all of these and I have not found this, then I'm going to print this that says I could not find this password. Now, there may be other processes out there that are still running away. In other words, if I have 10 or 20 cores and I have 20 processes running, or even if I have 2 cores but I've started a bunch of other processes, they are going to go and continue to run and pull messages off of this queue and continue to run and attempt to find the thing. We don't want them to continue to do that because they'll continue running when they don't have to. There will only be one password ever found. If that is the case, then what I'm going to do for my terminate queue, I'm just going to put an empty piece of data in it. Remember, this check password, what it's doing is it's checking the terminate queue to see if it's empty. And if it's not empty, that means, oops, we've been told to stop. I'm going to stop. So right in the middle of what I'm doing, I'm going to terminate at that point in time. And so that is what we're doing right here. Now, why do I have this sleep here? Let me just tell you, I noticed something strange in behavior where I put something onto this queue, and then when I go and attempt to clean up these queues to get rid of any extraneous messages, which I'm hoping there aren't any, but there might be, when I go through this, I found that when I didn't put a sleep time to allow the processing of these messages to get put in there, then sometimes, this is a timing type thing, I ended up missing a queue that I needed to clean up. So I put a sleep in here. I do not like this. I probably would have spent more time on it if this was a real project, but I found that just doing a sleep of 1 second has always caused it to work. Why do I print the queues out? Just because it was a debugging thing. I like the security of knowing, okay, these are all 0. Everything's going to work. If this was not 0, then I found during the development of this code that I ended up with issues, and the code would actually not complete running. Now, I may have fixed that by this particular point in time, but I may not have. So I'm assuming that I'm going to leave that in there. So that is the main program. Let's just run this thing once again. Let's say I'm saying processes. Let's say 10 processes, and I'm just doing numeric here. All right, let's do this. I'm going to run this. You can see I've started 10 different processes. So I'm going to pass in 1, 2, 3, and it's going to find it really quick. And then I needed to make sure that I terminated all of these other all of the other items that I put into the queue. There would be 10 items in the queue in that situation. Now, if I pass in a password that is 1, 2, 3, 4, 5, then as it goes through this, it takes it a while to find it. And once again, I need to get rid of these. I did, when I was working on this, I put in print statements to help me to find it. Just a tip for the for you guys to be aware of. When you're dealing with multiple threads or multiple processes, debugging can be a real pain because there's so much going on. Even printing stuff can be a pain, but sometimes putting in print statements so that whenever I ended up in a situation like this, I had print statements here, I had print statements here, I had print statements here, I had print statements when I got a message. All of this, doing print statements can be a useful way to do it. And now let me type in something. So I've asked it to run using numeric, and I actually haven't tested this in a while, but I'm going to do something like this, and this should actually fail, and it did fail successfully. It said password not found, ABCD. If I were to exit here, notice I did that terminate queue and I ended up exiting it. I'm going to run this again, and I'm going to specify minus alpha. So now I have alpha, and I have numbers. So I'm going to type in, and we should be able to see here, if I type in 111, it should happen almost instantaneously. Just for kicks, you see this one at the very end? This should take a little bit longer. Let's try ZZZ. Whoops. Let's see if I can type ZZZ. Typing in ZZZ. You can see it is taking longer to get through, so that took 3 seconds. It had to do brute force through every single one of these. And what I noticed is this, even though I only have 2 cores, I thought that having multiple processes would make it run slower, but it actually runs not too much different than when I have just 2 of these running. So anyway, if I was to put in this situation, I'm going to do 1111. And here's the thing. That first thread, actually, I'm going to put in 0000. I don't even know if this works. I haven't tested this. It should, but I've always been doing ones. Now this is actually going to find it really quickly, even though I only had I have 4 different characters. And if I do 1, 2, 3, 4, 5, notice that once again it finds it almost immediately. If I were to do ZZZZZ, this would take a very, very long time because it has to iterate through all of them. So that gives you a general idea. And if I were to do something, I'll just let this run, and then I'm not going to say anything, and probably we'll see if this ends up taking an extremely long time. I'll make it go fast for you. One thing I will point out is we can look and see that it's running extremely hard here. So you notice that both of my CPUs are running at 100%, and we're going to see it running at 100% for some amount of time. I'm not sure how many minutes this will take. Just as an aside, I will point this out. Brute force, yeah, you probably need more cores so that many things can be done in parallel. And in fact, this is a moment that I'm going to explain something while we're waiting. If you go online and you read about things like this, and you read somebody saying, hey, I'm going to be doing this brute force password cracking using a GPU, you may not. If you're stupid like me, you'll say to yourself, that must be a typo. Why would they be using the graphics processing unit that comes in a monitor in order to do password cracking? And that's actually not a typo. It's not somebody misspeaking. It is actually true. Why would they use a GPU? Well, to create this wonderful display that you see here, the newer monitors have graphics processing units that have many, many, many cores. And as you can imagine, the more cores you have, the better it is at figuring stuff out, the more things you can do in parallel. And let me show you why. We're actually going to look at stuff that I've already showed you before. So I'm going to let this clunk along in the background, and I want to point something out to you. Let's see, I'm going to go and use this one. And what I need to do is find my concurrency slides, and they're actually right here. So if you haven't seen my concurrency discussion, then you probably the video where I go into this, I have a sequence of them, then you probably want to do that so that you understand this. I do explain it. And my apologies, this is going to be going fairly slow. But here's the deal. When you use a single thread to do stuff in e.g. a networking environment where things are I/O bound, that is, you're doing things that block and wait for something else to happen, like pinging devices in a network or like doing input-output to a file, then using multi-threading is very useful. The reason is that you can do all of these things at once. So this picture is showing you that I'm doing everything all at once, and it goes very fast. And here I mentioned that our options for doing this would be threading or using thread pools or using async I/O. And I mentioned also multiprocessing is in there, and you might want to consider it. And so what I want to do is explain to you the difference between concurrency and parallelism. Let me show you this slide right here that shows you about what multiprocessing is. The idea of multiprocessing is I create separate and independent processes. And if you recall, when I talked about the issue with Python is when you do threading, there's this thing called the global interpreter lock. And the ramification is CPU-bound tasks may actually run slower if threading is attempted. That's why I did not do threading. It would have been very bad if we had done that. Multiprocessing, on the other hand, doesn't suffer from this, so I don't need to worry about the global interpreter lock. Now, the problem is that I actually don't have input-output type stuff going on, and consequently, what I'm trying to do is not so much this concurrency idea, is I'm trying to do parallel processing, as I show you in this picture right here. So basically, I'm doing computation, and the more cores I have, imagine these being separate cores, the more cores I have, the more I can do things in parallel. That's this word right here, and that's what we're trying to accomplish. And that is why we are using multiprocessing, and why the fact that I only have 2 cores is causing this to take an extremely long time. Now, I actually, just as an aside, I have my little Raspberry Pi. I don't think I have it up and running at this particular point in time, but my Raspberry Pi has 4 cores, and I thought that would be good, but because my Raspberry Pi is a very inexpensive unit, it actually runs slower than my 2-core laptop that is 5 years old now. So anyway, I'm going to shut up right now. I will speed things up. I'm going to get this out of the way. Hopefully that made a little bit of sense to you. I'm going to let this run, and yeah, probably this time will be different by the time this comes back, and I will speed it up for you. Actually, here, you want to look at this? This is me recording, so you'll actually be able to see it go really fast. Okay, so that took a whole lot longer than I thought. Here is my ZZZZZ. You can see it took 11,925 seconds. And I did the calculation here. That is 198 minutes, which is 3 hours and 18 minutes or something like that. In other words, it took a really long time. And I was surprised at that. I thought it might be a bug. I suppose it still could be a bug technically. I eventually came back. I tried just ZZZ. That happened in about 2 seconds. 4 Z's took about 163 seconds. So that's less than 3 minutes. So you can see when you add just one extra character, that's only 5 characters. And remember, that is only using these search characters here. I don't even have special characters. So you can see how long brute forcing takes, but yeah, that's basically it. So hopefully that gives you a little bit of an idea of what we're looking at. And if I were to just run this and do 1, 1, 1, 1 with 4 of those, you see how fast that is because it finds it starting, because I'm always looking at 0 and 1 first. In fact, if I was to do 0, 0, 0, 0, 0, because it's going to be the first thing that it looks at, it finds it in 0, 0, 2 seconds. Now, I could do funky things with this, with the search, with the brute forcing. I could start at a random location, but over time, it's not like that would really help out a lot. If I had an idea what people started with in terms of the first character for their password, that might help me to get an answer sooner. But as you can imagine, there's really no guarantee. Anyway, that is the brute force password cracking code that we've been looking at. Alrighty then, let's review what we talked about in this lesson. In this lesson, we're talking about cracking passwords. I created or renamed this module to reflect that. I have 2 modules in here. We talked last time about using a dictionary. I actually created a slide that sort of showed how we just took a hashed password and used the file method and dictionary method and database method to get at that. And so we learned a little bit about that Python-y stuff there. Now in the brute force world, I'm creating an application that looks something like this, with the main process that creates these multiprocessing processes that get created and that read from a queue. So we learned about how to do a queue. We learned about how to do processes. And the general idea with brute force is that you iteratively go through every possible combination of every possible character, and you see if it matches the actual password. And if it does, then you've found it in some way. So basically, I'm using this as a springboard for talking about queuing, talking about multiprocessing. The code that we looked through looks something like this. We're going to be taking in arguments that allow us to have the number of processes set, because that is going to be an important criteria. We set it to the number of cores by default. We can test against numeric, alphabetic, as well as special characters. As we saw in the lesson, it can take an exceptionally long time to crack a password if you're using a bunch of these together and the password is of any length. I have a function called check password that we talked about. This is what gets called in our process. So when our process is running, it's actually running the code that is check password, and that is where we generate all of the potential alternatives, all of the permutations of possibilities, and check to see if it matches the actual password. And we did mention that there's a contract between this mental contract between this particular process and the caller, in which case it will always return some type of message, whether it was found, whether that's true or false. So we're dependent on that in the main program. The main program uses 3 queues. Remember, we have the request queue, which is what is shown in this picture. Request queue sends requests for doing password generation and comparing that against the actual password. We create the characters, we spawn the processes, and then we loop in this loop where we get the password from the user, and then we put into the request queue all of the different requests that we want to make. And remember, the way that I chose to do it is I put in a request for every first character in the potential password. So if that's 0 through 9 only, then there will be 10 different messages that I put in the queue, and they will start with 0, 1, 2, 3, 4, etc. And if I have multiple of these, like in this situation here, then I'll be putting this many items into that queue. So that's what I do. After I'm done with that, I get all the responses back. So I sit through here. Once I found a password, then I am going to actually print it out, and then I'm going to tell everybody else I'm going to quit the loop, and I'm going to tell everybody else to terminate. Everybody else terminates. I have this for safety's sake. I get rid of everything that's left over in these queues, because every time through I want to start with a clean slate, meaning empty queues. and I loop in there forever until the user doesn't type anything in, and then I exit. So that was the code. We looked at how it actually worked. We saw that something like ZZZ took a fair amount of time because that's at the very end of all of my brute forcing. When I had 4 Z's, then you can see it took, 2 minutes and 40 seconds or something like that. And as you may have seen, I'm painfully aware, I actually left the house and came back, and it still hadn't finished when I had 5 Z's. So yeah, if you're looking for a real tool that does things in the most intelligent way, this probably isn't it, as I mentioned. But if you want to learn about Python, and we're using this as a springboard, then you can learn about queuing, multiprocessing, etc. through the code that I've created and that you can pull down. So hopefully this makes sense to you. I know this has been a long lesson. There was a lot of things to get through with all the queuing and the processing, etc. But hopefully it made sense, and hopefully you've learned something. So if not, or if you have a question, please shoot it to me via comments or Twitter or however you choose to do so. Anyway, thanks for listening. See you next time.